Part 2 of Chapter 19, Electrostatics Problems, starting with number 76. Here we've got a mass suspended in an electric field that is also balanced with a tension, and you're asked to find the magnitude of the electric field as well as the tension. So first thing I would do is always go to my free body diagram, where if this is my charge here, it's a positive charge, so the force due to the electric field would be the same direction as that electric field. And this angle here is 30 degrees. You'd also have your easy money force, the force of gravity, and you'd have the tension back to the left. So this is just an equilibrium problem. Some of the forces in the x equals 0, some of the forces in the y equals 0. Remember, sometimes you get points just for writing that. And the force due to an electric field is Q times E. So if I set this up, looking in the y direction, we'll start in the y, the opposite side, so Fe sine 30, the component of the electric force upwards, equals the force of gravity. So QE sine 30 equals mg. So now I can plug in values. 44 times 10 to the minus 6 coulombs times E, the electric field, times sine 30, which would be 1/2, equals the mass, 0.0037 kilograms, times g, which is 9.8. From that I got that the electric field strength is 1648 newtons per coulomb. And I can use that now in the x direction. We're in the x direction. The horizontal component of the electrostatic force, Fe cosine 30, will equal the tension. So QE cosine 30 is equal to tension. So plug in 44 times 10 to the minus 6 times the electric field, 1648, times cosine 30 equals tension, and I get that the tension was 0.063 newtons. The next problem I'm going to look at is 78. And fair warning, this problem or components of this problem often wind up in the AP test. And in 78, you've got a charged particle. This is actually an electron, so this is a negatively charged particle, entering an electric field created by two parallel plates, creating a capacitor. That electron is deflected down by 0.618 centimeters as it's going through the plates, and it wants you to A, find the magnitude of the electric field. So let's think of our free body diagram here. We would have, I think on this one, does it say? We'll go ahead and put in gravity, but often you can ignore gravity. So we'd have force gravity down, and this is an electron, so we'd also have the electrostatic force down. So the net force would be the electrostatic force plus gravity, and that would equal MA. This is QE plus mg equals MA. 1.6 times 10 to the minus 19 coulombs times the electric field strength, E, which we don't know, plus the mass, 9.11 times 10 to the minus 31 kilograms, times gravity, 9.8. Notice why it kind of cancels out. This is the negative 31st power, that's the negative 19th. That would equal our mass times A. Now, where would we find the A? Well, luckily we've been studying physics for a while and we got pretty good at motion back in first quarter. So we can use kinematics, where D equals VIT plus 1/2 AT squared in the vertical direction. This becomes like a projectile. And so the displacement is 0.00618 meters down, so negative. That will equal the initial velocity, which is 0. So this part cancels out, plus 1/2 times the acceleration times the time squared. Where do we find time? Well, while this is accelerating vertically, it is going at a constant velocity horizontally. So we can use V equals d over t. So to find the time, I did the horizontal distance, 0.0225 meters, divided by the velocity, which was 5.45 times 10 to the 6 meters per second. From that, you could get the time equal to 4.13 times 10 to the minus 9 seconds. Once you got the time, I was able to get the acceleration as 7.25 times 10 to the 14 meters per second squared. And from that, you can then get the electric field. When I did it without gravity, I got 4129 newtons per coulomb. I'd imagine with gravity we'd get something similar. Often ignore, because it's so much smaller. Then for part B, it asks to find the speed of the electron when it exits the capacitor. And this really comes down to like a projectile motion type problem, where in the x direction, the velocity in the x final would be your initial velocity of 5.45 times 10 to the 6 meters per second. And to find the velocity in the y, we do VF equals VI plus AT. VI was 0. This would be 7.25 times 10 to the 14 times time, which is 4.13 times 10 to the minus 9. And then to find the resultant. And when I got the overall resultant, I said it was 6.22 times 10 to the minus, or to the positive 6, meters per second. And it had just asked for the speed, so that just says magnitude. So that's good to know. Thank you.